Yeah, coming to the next presenter, it's a pleasure to introduce Markus Noack. Thank you very much. He will talk about the vertical connectivity, also an important issue in our river system, and he's from the University of Karlsruhe. And yeah, Markus, please, the floor is yours.
Okay, so can you hear me? Yeah. Good, great. So thanks, Christoph, for the nice introducing words. As already mentioned, my talk is about an evaluation concept for vertical connectivity and riverbed clogging in regulated river reaches. So first of all, I want to start with some background information. We already heard a lot about connectivities at this conference. Usually this goes back to the four-dimensional nature of logic ecosystems published by Watt, including the longitudinal, lateral, vertical, and temporal connectivity. And also this is quite an old concept. It is still in use. In 2019, Krill et al. Published in Nature a world map showing the so-called connectivity status index. We also saw this map this morning already. And the connectivity status index includes all 4 dimensions. And we look at the map, we can really see that in the industrial areas, of course, we have limited connectivities, and in the remote areas, we have quite a good connectivity. The paper also goes a little bit deeper. 90% of the limited connectivities are due to river fragmentations, which refers more or less to the longitudinal connectivity. And the other big issue is the flow regulation. This is the temporal connectivity. So in my talk, I want to focus not on the longitudinal connectivity, but on the vertical connectivity, describing the interactions between the river and the groundwater aquifer or the hyperheat interstitial. And usually the vertical connectivity is also connected to the temporal connectivity. I will go on this a little bit later. So when we are talking about the vertical connectivity, we also need to talk about riverbed clogging because it hinders the vertical connectivity. And at least in Germany, the clogging is one reason why we are failing objectives of the Water Framework Directive. So what is clogging? Clogging is basically the infiltration, but also the accumulation of fine sediments in the interstitial of gravel riverbeds, as you can see it on the pictures here. And from an abiotic point of view, this leads to a reduction of the pore volume, the hydraulic conductivity, but also to a reduction of dissolved oxygen. And this is having a biotic impact, especially on macroinvertebrates, but also, for example, on the reproduction of gravel spawning fish. So we developed a multiparametric approach to assess riverbed clogging. We call it multi-PAC. And one important thing about this approach is that it's a quantitative and a physical-based approach. So we are not working with some qualitative data like class 1, class 2, class 5, and so on. We really want to have physical-based values. And therefore, we are using the particle size distribution based on free scoring. We measure the porosity using a photogrammetric approach. And for the dissolved oxygen content, as well as for the hydraulic conductivities, we are using a novel method with a double packer that allows us to measure vertical profiles of the dissolved oxygen content and the hydraulic conductivity. We applied this approach at the German part of the River Inn, and as you can see on the figure here, we have a chain of run-of-river plants, and this is leading to more or less no free-flowing sections anymore. You can also see some characteristics of the River Inn here, and one common restoration measure here is the installation of bypass channels. And sometimes these bypass channels are constructed in a way that they can freely develop from a morphological point of view. And of course, you can also control the discharge, and this allows the artificial flushings. And so the basic idea is more or less on the one hand, of course, we have the longitudinal connectivity, but with the artificial flushing, the aim is to initiate bed load transport, regular bed alteration, remixing of sediments, or flushing out the fine sediments, so to say, to declog the river and restore the vertical connectivity. So I want to talk now about this bypass channel here. It has a length of 2.6 kilometers. The width is approximately 10 meters. There are no bank fixation. The bank for discharge is around 12 cubics. And we applied our multi-pack approach before and after a flushing event at these 3 different sites. You can see it on the pictures from our drone so that you just have an impression of the dimension of the bypass channel. And if you look now at the first results from the particle size analysis, this is more or less kind of a bulk sampling over a sediment depth of 50 centimeters. We have in the light color the situation after flushing. The darker color is before flushing. And the sieve curves here already show that we have a coarsening of the riverbed. Yes, and this is also confirmed if you look at the fine sediment contents here shown for sediments less than 0.5, 1, and 2 millimeters. They are decreasing due to the flushing, and the porosity is slightly increasing. So more or less we can say, okay, based on the particle size analysis, we get a coarsening of the riverbed due to the artificial flushing. Okay, let's have now a look on the vertical profiles of the dissolved oxygen content and the hydraulic conductivity. So here we can also see an improvement of the values. Again, the colors or the light colors are after flushing, the dark colors before flushing. And especially in the upper 15 centimeters, we can see an increase for both parameters. And the interesting thing about this is actually that we can more or less determine the depth impact of the artificial flushing. So what depth is mobilized during the artificial flushing. Good. Same river, different hydropower plant. So now we are in a residual river reach, and there we investigated 3 different travel bars. And again, we can see here the vertical profiles of oxygen and hydraulic conductivity. And if you look, for example, at the KB24 in the middle, we have the profile. I think it's not possible to see it. So it's an oxygen profile with the lowest values, which makes more or less sense if you look at the picture here. But most interestingly, we see that for the gravel bars, we get quite different profiles for the saturation, for the oxygen saturation. But the hydraulic conductivities also show some differences, but not in the same order of magnitude. And maybe one reason can be that we have higher respiration values at the gravel bar KB24. And this also underpins our assumption, more or less, that regarding riverbed clogging, we cannot work with a single parameter to describe this complex process. And that was more or less also one reason why we developed this multi-parametric approach towards an assessment of clogging. Good. Well, but how can we evaluate now those measuring results in terms of clogging or in terms of vertical connectivity? So what do we need if we want to do an evaluation? And therefore, we need reference values. Reference values that give us an idea what kind of physical values do we have in a natural state, or if we have in the rivers where we do not have any human influence. And therefore, we are currently working on a research project funded by the German Federal Environmental Foundation to develop a river type specific evaluation concept. This means we are only looking at silicate-based coarse-grained rivers. And based on certain selection criteria, we selected 7 rivers. We did 3 measuring campaigns where we applied our multiplex approach. These were all sites where we also had data from the Water Framework Directive. And the table just shows the ecological status of the 7 rivers, as well as the indicator general degradation. This is an indicator describing structural deficits or, let's say, the morphology. The overall goal is to derive more or less some reference values based on the measuring results in these rivers. We are also looking at the catchment characteristic, and we also want to evaluate temporal aspects. But this is still ongoing, so this is still something what we have to do. We subdivided the rivers into 3 categories regarding the general degradation. So in total, we had 4 rivers where we have near natural state. We have 1 river with a poor situation and 2 rivers with intermediate